Development began in Adobe Illustrator, designing button icons and testing arrangements for all 20 buttons. Key electrical components were then drawn in Illustrator, which matched their actual dimensions, so I could size the button layout and plan the PCB. The LCD screen and infrared receiver were then added to complete the Illustrator file, giving me a full component reference at correct scale for both the remote face and for SolidWorks modeling later on. Initial experimentation on electronics began with attempting to make a resistor ladder, which detects multiple button presses on a single Arduino pin, displaying this output on a 7-segment display in Walkwi, which is an online simulator. This was unsuccessful and required more research into resistor ladder functionality for the next test. Using online designers as a reference, I rebuilt the resistor ladder and got it working reliably. It worked for 5 buttons, but gave inconsistent readings. It also only detected one button at a time, confirming I needed a different approach in the future to allow multiple button presses. Infrared signal transmission was then tested between 2 Arduinos physically. The communication worked, but the ladder shorted out when multiple buttons were pressed, reinforcing the idea that I needed a new button method for my design. Since I had planned all my other components for my PCB, its design began in KiCad, in the schematic. In this process, I realized I needed a system for the battery, and I also needed to choose the system components in the future. During this process of designing the schematic for the PCB, I learned the functionality of a button matrix. It reduces the total pins, whilst also allowing multiple buttons to be pressed at once. I did not start the wire tracing yet, as I had not decided the specific components to use. A tactile button and its cap were sourced from SnapMagic and GrabCAD, imported into SolidWorks, and then assembled to confirm they fit. This gave me accurate dimensions where I could import my button designs from Illustrator and evaluate their aesthetics to make changes early. This full button grid was then laid out in SolidWorks using the linear pattern feature. Testing a green color confirmed that the color coding by function would make the remote easier to read and use, whilst also keeping its aesthetic. All internal components were then brought together in a SolidWorks assembly. This is where I confirmed that a TFT would be the best display for the remote, given its compatibility with the ESP32 and its flexible sizing to manufacture it. Since the PCB had now been sent off, I could start the remote's case in SolidWorks. Since I wanted it to be comfortable to hold, I started with a pill-shaped profile, which took a couple of iterations to get correct. This was much easier to do though, because I had the PCB imported into SolidWorks which verified the internal clearance of it. I came back later and fixed the pill-shaped remote case. I then finalized this initial casing with 1.8-inch TFT cutout which aligned with the female header pins, a hole for the USB-C connection, PCB mounting rods, and custom button tops. I then began the ideation of my product logo. I had previously settled upon the name of CourtSync, which reflects the high responsiveness and functionality of the device and its area of use, the basketball court. I wanted the product to feel premium and well produced through the logo. So with some help from my teacher, we came up with a design with a sink shape, replacing the sink slightly angled to represent the fast input and the 3D wall of a court. An initial website was then built on Wix to test layouts, colors, and imagery. The first version identified what needed improving, but also built skills for the next iteration. Stronger imagery, better typography, and a darker theme would be consistent with the product's identity and logo. So I redesigned the website with some help by Claude, where I made a new site with product descriptions, the logo, and multiple images which represented the product's functionality. Since my PCB has not been delivered due to many delays, an animation of the functionality shows a combination of the parts I have used. Here the number 65 is entered with a 3-point shot, and then with a foul. It updates this to the scoreboard. This statistic is seen with the info button and then is cancelled with the cancel button, which also then changes the scoreboard. This is done through an IR LED.
G'day, I'm Harrison. I'm Thomas Gordon's mentor for his basketball remote project. I'm glad he's pursued something he's interested in because, as seen throughout the portfolio, his on-the-ground experience with basketball refereeing has shown that he knows the issues with the current designs, and through his iterative design process, he's selected the best in breed across all the existing products, and he's merged that into what is his proposed product here. If I had to make some suggestions, I'd like to see a bit more commentary on the repairability of the remote. That was raised as an issue with the other systems, but that wasn't pursued further. Additionally, some bumps on the buttons as well. For instance, the F and J keys on your keyboard have bumps on them so that when you're not looking at them and you're touch typing, you can quickly realign yourself. If a referee's running around the court, they don't want to be looking up and down at their remote all the time. My final question is around the strength of the IR LED. A TV remote really only has a usable range of 5 or so meters, so it'd be interesting to see if that strength of the LED is able to go across the court. But otherwise, I wish him luck with his product and his portfolio. I think he's done a great job.
Based on this, my next steps are to review the PCB and take in its strengths and weaknesses into my evaluation. Taking into Harrison's advice, I think it is a good idea to look into Wi-Fi and Bluetooth, as IR LEDs do have a limited range compared to them. I also really liked his suggestion of using ridges on the buttons, so it's easy to identify the buttons without looking at the remote.